Hello everyone. So I think this video actually I'll try to make it a little different from the other ones is that we will try to do some hands-on stuff. So this project number 3 is actually runs Ollama, FastAPI, and Chroma. So what I'm trying to do here is basically I'm trying to build a simple RAG with a vector database and an API where we can send a request, and we're trying to run our Ollama where we can do some AI generate response. As I mentioned, Ollama is a simple service that allows us to run our AI models. And you can see here, this is to my previous videos. You probably watched about Docker Compose, and this is a Docker Compose. So it's called PR3 Ollama FastAPI Chroma. So what we're doing here is we have multiple containers that defined in a YAML file. It was really quick to set it up, but required some troubleshooting. So we have an API container, we have a Grafana container for our APM, right? So application performance monitoring, and then Prometheus. This is the source for Grafana where we're gonna feed all our data, and then Chroma. This is the vector database. Now, guys, vector databases are databases that work greatly with the AI and AI agents, specifically because they are kind of very they take a different approach comparing to the relational databases or other databases like NoSQL databases. So they work of things called embeddings, and what they do is that embedding models usually they are the way they work is that they work based out of an approximate nearest neighbor (ANN) algorithms. So these algorithms basically they try to find the closest match to the data that you're trying to request. So what happens is that in RAG, system finds the similarities and then feeds them to the LLM to generate responses using the retrieved information. So basically, we're trying to get the information from our vector database and then trying to combine it with the LLM response. So how does that work? Usually, the thing is like, for example, I'll give you an example. Let's say there's an actor named John Smith, and he played in a movie called, Lions. I don't know, like a lions. Let's say lions controlling the pride or something like that. And so John Smith is an actor. So if I supply that answer to the LLM, what happens is that LLM is going to think, okay, I have to retrieve the information based out of my knowledge that it was the data that I have. I have to find the information about the John Smith actor. Now, when you have a RAG, you're basically connecting your vector database to your, let's say, hospital information. So now next time I ask, who is the John Smith? It's not going to pull out the information about the actor, but it's going to pull out the information about the John Smith, the patient that we have out of New York, for example, and who has a cancer, right? So, and this is just an example of how the RAG and vector databases work. This is a very simple example. Now, I built a very simple power stack. So RAG, building a modern AI powerhouse. And again, I'll share this document in LinkedIn. So we're using is Ollama, we're using FastAPI, Chroma, Docker, and Grafana. So there will be multiple videos to this session. So please just follow along and follow along the document as well, and let me know if you guys have any questions. But I will try to make sure that it's we try to stay within the 5 minutes and try to make it short, not too long. So we're gonna just cover a couple of slides, and then we're gonna break for the part 2. So from lab to production AI systems, in this project, what we're trying to do is we're combining AI models, APIs, vector search, and monitoring into one system. So this is really cool. This is part of a Docker Compose. That's Docker Compose. The reason why it's really cool for like a playing and building really simple agents. This is a real world setup showing how AI agents can be deployed in production. So this is for the systems engineers like us. This is like a Docker Compose, and Docker is your best friend. You want to just cook really, you want to move really fast, and then take this into something like KH cluster, make it much more fancier using EKS or ECS or AKS or GKE or other platforms in the cloud providers. So just take it very simple and then scale from there. Don't go right away trying to scale, which is going to make the life miserable. So coming back to the project a full AI stack using Ollama to run multiple models locally. So we're using Ollama to basically run our AI models. FastAPI to provide a secure API layer. So you've guys seen it's a Python method function, whatever it's called, and this basically allows us to run the APIs to our application. And this is the API service right here that I have. And if I go to the logs, you can see here all these requests that I've been trying to send, and it says 200, okay. And then we have a Chroma as a vector database for retrieval. So the Chroma is actually is one of the vector databases. You probably saw in other projects I've used Quadrant. Quadrant is also another vector database, and in this case I'm using Chroma. So for this app we're going to use Chroma. When we're going to come back to some of other AI agents that I've done, we will come across the Quadrant. So in this case we're using Chroma as a vector database. Like I mentioned, vector databases, they use embeddings, indexes, and basically what it does is that it tries to find the nearest match for the type of an information you're searching. Docker Compose, there's a lot of content out there, guys, about the vector database. You can search it up. Docker Compose, we're running all these services out of a Docker Compose because I want to go very simple and very quick. And then Grafana and Prometheus for monitoring observability. We'll try to see a couple of metrics. Just try to monitor our app. Try from the side of the SRE perspective, site reliability engineering, and we want to make sure that we have some kind of a monitoring, right? So some kind of logging solution for this. This setup is like a mini production AI platform. So if you're trying to understand what's going on in here, just go back to the other previous videos and the documents. They're very short, and just enjoy and try to go over that. With that being said, before I continue, we're going to break for part 2, and it probably is going to be more parts to this because we're going to have to do the demo as well. But thank you, and please stay tuned. Bye-bye.